Good morning, I'm John Cirucci. I'm a master's student in the Geographic Information Systems program at Penn State. My co-authors are my advisors, Douglas Miller and Justine Blanford, who's here with us today. And our topic is retrospective GIS-based multi-criteria decision analysis. As a case study, we've selected the siting of waste transfer stations in California. We're making decisions all the time, and they almost always involve multiple criteria. But usually our decisions are very simple, and those criteria are considered implicitly. And more often than not, it's just one person making the decision. Multi-criteria decision analysis, or MCDA, refers to the formal approaches, collection of formal approaches, where criteria is considered explicitly. And this would normally be applied when there's a very complex decision and the impact is high. GIS is often used in spatial decision support, so it's natural that GIS and MCDA are intersecting disciplines. And in fact, there's been a growing number of publications associated with GIS-based MCDA across a range of decision problems and domains, with more than 1,000 papers devoted to this intersection of disciplines. Very simplistically, looking at an MCDA workflow here, of course, a problem is identified, and then there's a problem structuring phase, and that, most importantly, is identification of the criteria that will be considered and the alternatives or options that must be looked over and amongst which a choice will be made. And then those criteria and alternatives are put together into a decision model, and there's many different types, in a model building phase, where in some way the criteria is assigned a preference, and that information is rolled together to put a value or rank around the different alternatives so they can be compared. It doesn't say, here's what you need to do, but it gives useful information to the people who are making decisions so that then they can plan a course of action. Many different methods and decision rule types. This area in operations research has been around for decades, but simplistically, we might categorize them into three classes: value, preference, reference point, and outranking. And in this study, we're going to focus on the first two. So our hypothesis is that given a large enough population set of similar historical decisions, we can interrogate that information, taking an inverse approach, to try to determine some of the subjective valuations applied to the problem by the decision makers and stakeholders. We're really kind of reversing a Ford theory, and a Ford theory where you take your model parameters and put it into your model to get a predicted result, kind of taking that backwards, taking observed results from previous spatial decisions, assuming various model forms, and then trying to find out what the parameters or the criteria evaluation might be for those models. As a case study, we've selected waste transfer station siting. Waste transfer stations are locations where municipal solid waste is collected, coming from smaller collection vehicles, and then transferred to larger haul vehicles so it can be taken to a final disposal site, an incinerator or landfill. And they often look like this: nice, shiny buildings on the outside filled with garbage on the inside. Waste transfer station sites are positioned between the source of garbage and a landfill or incinerator, where it might ultimately end up. And the purpose for this is because you want to shorten the travel time of these smaller collection vehicles, and then get this solid waste onto large haul vehicles where it can be moved over roads much more energy efficiently and with lower labor operating costs. So there's competing forces, though. Straight economics say move the waste transfer stations as close as possible to the source, but no one wants a waste transfer station in their backyard. So the NIMBY issues take hold. And that makes this an interesting problem from a siting standpoint, because we have these competitive forces that go into the siting decision. We can't just run the MCDA process in reverse. We have to have some understanding up front of what the problem looks like. So really what we're doing is a problem structuring phase, identifying likely criteria and possible alternatives. and then working backwards with the actual decision outcomes, then putting that information together in different decision rule forms to see if we can parameterize it. So as part of problem structuring, we start off with alternatives. For waste transfer stations, we actually honed in on California and then more specifically Los Angeles County because the data is available. California has a very transparent solid waste management database system. And there's regulatory consistency within states, so that simplifies some of the uncertainties in the problem. And LA County is the most populated area of waste transfer stations in the state of California, with 41 current large volume waste transfer stations. We had to then choose, well, what is a site choice? It can be an infinite number of points on a continuum surface, but we selected a 1 hectare lot. That conforms with the average footprint size of a waste transfer station in California, and it's a convenient unit to work with. There's over 1 million hectares in LA County. Then we have to choose criteria. So we can't just go in and assume it's the price of pork bellies and the weather in China. We have to have some bias in terms of selection of criteria and working off best practice siting guidance, for which there's a lot of information on waste transfer stations. And then practically just the availability of data. It's clearly stuff that goes into these decisions. We're not going to be able to ferret out. A lot of them involve a lot of local politics and things like that. So we're kind of glossing over that. That's going to contribute to the uncertainty of our models. But the information that we know is important and that we can get our hands on. And we've also incorporated some of the social demographic information because there is, unfortunately, a history associated with waste transfer station siting that shows there's some correlation there. The data comes in many, many different forms. So in order to aggregate it, convert it into something in common, everything has gone to our 1 hectare, 100 meter square cell size raster layers. All the data is converted to a common form, which generally is at a higher resolution than most of the data. So we're not introducing aggregation error directly from doing that. We also have to do some spatial data transformations. It's not necessarily important to know what the income level is at a waste transfer station site. We want to look at the neighborhood. So for a lot of this information, we do a neighborhood analysis and do averaging to a point so we get a neighborhood characterization of that information. Transportation is really important, so we'll also have to consider not just Euclidean distances, but over-the-road distances, the transportation network, including road type was applied. And because time is maybe a good equalizing factor, we've kind of converted everything to a proxy travel time based on the road network and road type. Then all that criteria in multiple raster layers was collapsed down into one single large database, mechanically in GIS converting it from raster to a vector form. And the result is a large array of data with a million different cells and 27 fields. Now, with that, we can start looking at fitting decision rules. And in LA County, as I mentioned, there's 41 current sites, so those are our present sites. And there's over 1 million where there's no waste transfer station. So what we're trying to do is describe how does this criteria of the present location support the decision to put a waste transfer station there, fitting it to 2 different MCDA decision rule types. So I'll start with value preference. And this is a gross simplification of the many, many different value preference systems. But a way of thinking about it is in value preference for a given alternative, we assign partial values to all the criteria. That might just be a simple matter of weighting their values according to their importance to the person making the decision. Then that is aggregated, which can be a matter of summing it together or doing some other kind of mathematical manipulation to get a value for each alternative. Those values can be compared, and that's information that the person making the decision would use. So we have to kind of, we don't know what process was used on these, assuming a very simplistic form where weighted criteria is then summed together to come up with an alternative value. We regress that information. And doing this retrospectively, we have to consider the fact that our dependent variable is binary. Either a waste transfer station is there or not. So we fit it to a logistic model form. That's just a convenient way of taking a linear model and then converting it into this function where at its limits it goes to 1 or 0, corresponding to the presence or absence of a waste transfer station. Maximizing goodness of fit and minimizing the number of criteria that don't add to the value of the model. And that's important here because what we're really trying to do is identify which criteria is significant by itself and assign some sort of weights to those. The nice thing about the logistic model form is it is, in fact, ends up being a probability. So the resulting outcome of this is we develop a spatial probability. So we did that. Of our 27 criteria, 11 of them were identified as significant and non-linear, and they're shown here in this normalized bar plot. These are the weights assigned to them. Not surprising, and I guess good news in terms of the model fit, is the transportation economic factors dominated this. And actually we have information about their relative importance. I talked about the position between source of waste and the disposal station. You can see travel time to residence was actually the single dominant factor here, about 3 times greater than travel time to disposal. However, we found a number of other demographic factors that were significantly correlated, including gender, ethnicity, income level, housing. These were significantly correlated. Correlation does not imply causation, and we hope that the people making the decisions about these waste transfer stations did not decide to put them in a large population of females or Hispanic Latino origin neighborhoods. That probably was not explicit in the decision process, but it does point us to the fact that these are significant. There may be other dependencies that we would need to understand, perhaps missing criteria that's relevant here. So it's important information. Now we can take that probability model and map it. This is LA County in the background, and I've zoomed in on the city of Los Angeles so you can see some of the resolution. The darker blue areas correspond to the high probabilities in the model. They correspond very well with actually the waste transfer station sites shown with the yellow triangles there. The actual mean probability at those locations was about 0.2%, which is very low, but we're talking about 40 stations in 1 million hectares in the county, so it's winning the waste transfer station lottery is long odds in California. However, that is significant compared to general locations, about 40 times greater than the general probability across the county. Now we're going to switch gears, look at a totally different decision rule model, the reference point decision rule. And again, in the simplification here, the way to think about this is that in reference point, for a given criterion, there's a reference level that is subjectively identified by the decision makers that must be satisfied. And those alternatives that satisfy that reference level are accepted. Those that are not are eliminated. You march through all the criteria and effectively filter out the alternatives, perhaps ending up with one, more likely ending up with a couple or none. So it's really an iterative process. But this is actually how many decisions are made implicitly. You came here and probably decided, I want to get to Detroit, spend less than $500 on a flight, and it needs to get here by 8 p.m. That would be a reference point decision rule model, effectively. So we want to try that, to apply that retrospectively to this case. We can't regress the data. We're looking for a threshold. So the way we approach this is to develop Pareto curves for the locations, black being all locations in the county and red being the selected locations for the present waste transfer station. Putting that on this is a relative Pareto for each attribute. So you can look at how they cumulatively increase as the attribute value increases. And what we're looking for in terms of identifying a reference point is there an inflection in the ratios of these curves? If there is, we can say, looking at this curve, for example, following the red line is, the attribute is getting higher and higher and higher. That's good. And then all of a sudden, it seems like we've met a point where we're satisfied right now. That's good enough, and that's the identification of the reference point. And if all reference points are satisfied at the ideal locations, that's the essence of this model. So we don't end up with a probability model, we end up with a satisficing model. Let's look at these results. Once again, identified 11 criteria. not the same ones though. So the 4 of them were actually different than those identified in value preference methods. And some of the criteria that definitely were important did not yield a reference point. So it doesn't mean they're not important, it just means there isn't a threshold level that seems to be achieved with those criteria. I did a further classification just because sometimes this was very clear to see and sometimes it was a little bit subjective in terms of identification. So specifically, the distinct thresholds were classified as Tier 1, and those that were indistinct defined as they occurred at a point where less than 50% of the actual waste transfer stations would be included, or there was variability in the slope change that made it unclear if that was the exact threshold. So classified then as Tier 1 and Tier 2, just kind of understand that there's not, some thresholds are more obvious than others. So here's a sum of that. The top line shows in orange the present location, relative frequencies that made the test, that satisfied all of these criteria thresholds. And you can see about 50% of the actual waste transfer locations satisfied that goal versus about 10% of general locations. So we didn't kind of catch everything, but we definitely, applying this method, definitely showed a strong bias towards the waste transfer station. When I add in the Tier 2 levels, it drops down to about 40%. Another way of looking at it, which isn't really true to the decision rule model, is to sum the number of criteria for which we satisfy thresholds. And that just gives a different view at it. When we add all the criteria, it corresponds to this reference Tier 1 and 2 model. But we can see that all of the waste transfer stations have at least met 6 of these thresholds. Okay, we can put this on a map as well too. This shows the distribution within the city of Los Angeles. Once again, green corresponds to areas where all of the criteria have been satisfied, pink where they haven't. Very different kind of view than we saw with value preference. We didn't do such a good job of finding exactly where the waste transfer stations are. It's a little bit more modeled. Here's the Tier 1 and Tier 2, and this is that sum form, which shows a little bit more of a gradient. So, when we look at these two, we can say that the probability model versus the satisficing model, value preference, decision rule, outcome of a probability model corresponded pretty good with the actual decisions that were made. Very, very strong bias towards high probability for the actual locations. And we were definitely able to correlate some social criteria, which just kind of raises more questions in terms of now what do we do to understand why were they significant. The reference point decision rule, about 50% of the actual stations met the satisficing model, but many significant criteria just simply didn't have a threshold, even though they were important. There wasn't a level that was obvious, was satisfied in the history of the data we had. So this appears to be maybe a retrospective analysis that would be most useful when the decision history has a limited number of criteria that are pretty well defined. In summary, we were able to kind of run things backwards and reverse engineer this decision history, applying a couple of different decision rules. The outcomes give us some insight on what criteria is most relevant and potentially what kind of decision methodology was applied. These methods are certainly very generally applicable to any decision history involving spatial decisions where there's a large set of data. We had 41 cases here. The number depends on the variability, but you need to have a lot of decisions to kind of do this kind of statistical analysis. And you have to have the availability of the potential criteria. So future work will be to kind of balance things out and look at some other decision rules, notably outranking as our next step. Thank you.
Questions?
I wonder if you looked at different stakeholders. I know that the NAACP in their green perspective would be very interested in the research.
Yeah, well, strictly from the standpoint of who's making the decision, it's kind of interesting because some of these factors are probably not actually being directly applied by the decision makers, but influences by the many stakeholders. And that, first, of course, includes the community, but I expect there's a lot of organizations that pay attention to this kind of stuff. There was some work done in the late 90s, actually around waste transfer station sightings in Washington and New York, where some of the issues that we're seeing here were flagged exactly for that reason. So that's part of the reason we incorporated it into these results. Yes.
Sean, very interesting. But how do you see this being applied? How do you see this being applied in the future? Is this something that we can use this information, and how do we use it?
Well, right off, I'd say one of two ways are very obvious. First of all, in the commercial world where I come from, this is actually a really interesting way of looking at what other people are doing and maybe getting some competitive intelligence in industry, or I imagine there might be even military applications in that respect. But I think actually what's most interesting is because, as we've seen here, we're finding significance around factors that even the decision makers may not have explicitly thought was part of the process. We can learn a lot from the decisions we made, and now you have a way of measuring things. If you want to make a change, you have to start off with measuring your current state. And particularly around some of these social demographic issues, this is a good way of characterizing what actually is shown statistically to be embedded in as correlated factors. And that may influence changes in the way decisions are made in the future. Yes?
This is really fascinating. You're talking about the siting from an NIMBY perspective, and then it occurred to me that when you showed some of the facilities looked rather nice. Just wondering, are there still issues with like local environmental impacts associated with these facilities, or I can, having lived in Buffalo for a while, for example, and toured a fancy new recycling facility, it was touted as an employment generator for the local area, so it was almost a positive there.
Yeah.
I mean, different types of waste, but is it possible that some communities were trying to attract this if it was going to generate local, economic positive value?
Yeah, so the question was, is NIMBY always kind of pushing things away, or is there some of them, I want it in my backyard because of some of the value that it might bring, particularly in terms of jobs. We didn't kind of try to force any of these things on it, although perhaps if we wanted to specifically explore that, it may be other criteria that we want to include in our model, like employment rate and factors like that. So I think if you can almost query the process by bringing in factors where perhaps some of these other issues might be identified. Yes.
Do you see any opportunity for doing some interviewing of people who were involved in the decision-making process to get at some of the political or other kinds of issues, or even just to feedback some of this information and get their...
I actually have talked to some people in some commercial folks in this area that are big here, like waste management. The other thing I've done during the course of this work is LA County streams their meetings, their monthly solid waste management meetings. So you listen in on that, and you really do get an idea of what's going on here. What you kind of miss, though, in this analysis, and even in listening on those things online, is what is going on behind the scenes locally. Every one of these decisions is a municipal decision ultimately, and has a lot of those kind of influences. And that's probably some of the stuff that gets lost in the noise of this kind of analysis. It would be actually interesting to look at a large set of data, but then relate it to some specific decisions and see how they vary, considering those things.
Maybe one more?
Just a quick follow-up. You talked about how the political process is sort of noise. Have you thought about proxies for metrics for looking at, I don't know, like voter involvement in municipal elections or some other way to get at the political process from a quantitative perspective?
Very interesting. Not included in this study, but if you wanted to, once again, if you wanted to try to pursue those kinds of things, you might kind of bring up other factors in terms of criteria to throw into the model. The party orientation, voter turnout, probably a lot of factors that could be added on to test whether they turned out to be relevant or not. So it's an interesting idea. The process would allow that. You kind of have to go in that problem structuring phase with what do I want to learn and what do I think might be useful criteria to test.
All right, so I guess I have a question. So that question got my mind spinning, not in a good way. But so you've been looking at this field and you're applying it to a very applied situation. Are people applying the same kind of modeling to the societal issues as opposed to sort of citing issues, looking at influences of different demographic factors?
Perhaps they are. I've kind of limited my survey to spatial decision histories, and there's actually a lot in terms of social implications that might be tested there. But I'm not specifically aware of it, though I'd be really surprised if in the broader MCDA field, the decision analysis field, there's an awful work going on there.
Great. John, thank you.